Hello everyone. So I did some work and managed to get a more or less functional Arduino version here. Here is the connections. Everything is as before, as it should be originally. Of course, I don't have a battery here, unfortunately. I have that in my lab, but I am doing some tests now with a power supply, and of course it's current limited, so I don't blow anything up. But okay, let's say that this preliminary version basically has all the functionality of the original one. If you see, it has battery voltage, it has the milliseconds, and this one starts and it's not armed. I did it for safety purposes, because I don't know, if you just plug it in and you're not ready, and maybe your contacts on your electrodes are icy, and people have like even metal surfaces, and if they're touching something, you never know. So first of all, it turns on, but it's not armed. First thing you have to do is it's the same, very similar. You can increase the milliseconds. Okay, at the moment I did this little color scheme, like green until 20, from 20 till 50 it's like red and with a red background, you see, and then 50 becomes black, because I think anything over 50 is pretty an overkill. Anyhow, that's just, I will maybe leave it in or not, it doesn't matter. But most importantly, you have the battery voltage, which is I'm using the voltage divider that they had to read it, and it's very precise. What you do is you click, and you have this. Now it's in automatic. Don't notice that 0 there, that will be removed. It's just a debug thing. So when it's in auto, if you don't do anything for a while, it will disarm itself. I got this from RC stuff. I don't know. I like things that, you see, I like things that disarm themselves, because if you're not using it, and you have, like, again, contacts lying around with a big battery connected, it's not really safe. So these are things that I personally implemented. Maybe people don't like them or whatever. The delays can be increased, whatever. But anyhow, so you have the automatic mode, the manual mode, and this works with the trigger here, as usual. And okay, in automatic mode, if you just simply touch these together, it will trigger. Of course, I have a limited current power supply, so it just when I trigger it, and if you keep it triggered, it will just stay there. It will wait until you release it, and everything will stay in this endless loop, and you can release it, and then it will recover. And touch it again, and then release it. Okay. As I said, maybe it's not the best way. I tried to get the timing precise. It's more or less precise. I think maybe there can be a variation, 1 millisecond more or less, but it disarmed itself. So I will do these tests now with of course a beefy battery, and see what happens. I did notice that with my scope, the trigger, now what I'm doing is I'm using the Arduino here directly connected to the base. I'm not using any resistor. I tried with about 560 ohm resistor, and yeah, it was about it's still around 6 volts. Okay, I'm not getting very high voltage, but that may be also because I'm voltage here, I didn't check, but I was using a lower voltage, even if it's got regulated. This has a 3.3 volt regulator, and also this board has one, and it's running off this regulator now, because I connected it to the regulator output, and so it may be a little bit low, but okay. I will do the double check that and see if it works. For sure, the cap is keeping this on. So as you can see, when I do use it, okay, you need to put automatic here. It doesn't blank out because it simply freezes everything on the display and it stays like this. That's all. Basically, yeah, that's my progress at the moment. So I repeat, this is on this revision, which is a BK. Mine is a BK11, but I've seen that they have also BL. A user sent me his video of his version, which is practically identical. It has a couple of resistors added on the driver section. I don't know how the circuit is, but I think they did some slight modifications. Then I've seen another BK something else, which has an identical circuit layout as this one. So yeah, there are, I think, at least 3 revisions I've seen which are based on this one. And probably, I don't know which ones have the same problem, but okay, the user who sent me his video of his the BK, or rather the BL22K version, I think that's the name, it just doesn't work. It doesn't trigger. So I think there is a driver problem as usual. I'm not surprised because it's to be honest, to drive these FETs properly, you should use a FET driver. It's an IC and it has a very fast switch on, a very fast switch off. As I said, maybe this is enough. I don't know. I'll try and do some tests with the battery and see if everything blows up or not. Big deal. I mean, I have nothing to lose. But at least I have this display here and the setup, which is reusable. And the FETs underneath, as you see, I still have 4. I didn't get the other replacement one, but it will still work. If you wire this properly with thinner wires or kinder wires, or even copper enamel wires, this fits comfortably under here, and there's a lot of space. You can isolate it and put the Arduino Pro Mini 3.3 volts. Remember that, because this screen, the regulator and everything, this is 3.3 volts. So if you do use a 5 volt one, I'm not sure that the output, that the 5 volts is accepted or handled by this kind of controller here, the ST7735. That's OLED. I wouldn't risk it. I don't know what this stuff is. I had to do some modifications to the driver, the UCglib driver. It was for the, let's say, general ST7735 displays out there. This one is a little bit different. It's inverted. It has let's say a slightly different resolution, but I modified it in the header file, so it's fine. It works. As you see, it's black now and the colors are working fine. So I don't know. I will just try and see if, as I said, it works, and if it does, release the code. So it's not really optimized. It's just let's say a quick and dirty job. I was just curious to see if the whole thing was working. I wrote in the code all the pinouts. Let's say this is the display. These are the Arduino pinouts. How to wire them, because of course this is the divider for the voltage sense that tells you the battery voltage. And then there is one that gives you the trigger, which is they're all wired for a scale of up to 20 volts. This is the design. I mean, it's 5.7K maximum, 4.71K here divider, and that works until 20 volts. So yeah, that's basically, you're going to be using 12 volts. I think I might be adding low voltage protection, meaning that if the battery is lower than probably, I'd say 12 volts, it will not trigger, just for safety, you know. To be honest, the voltage is not that important, because you might have an 11 volt I don't know, 200 amp hour power supply, and it will work fine. The thing is that, generally speaking, if you're using a 3S, your battery is going to be at least 12 volts if it's charged, hopefully. If not, better charge it, so that's why. And if you're using an AGM battery and it's not 12.5 volts, then if it's 12 volts, then it's probably dead. So based on this information, I think it's a good idea to put in a cutoff or inhibitor if the voltage is under 12 point, say 12 around 12 volts in general. At least you notice it, and the voltage, maybe you can put a red box around it or something and beep. Well, that stuff is pretty easily done, all in code. I mean, it's not what I was more interested in. Was the driver stage, which is actually the most critical part. It's the easiest but the most critical, because as I said, the Arduino is pretty fast. When it enters the timing loop, it does just that, timing. It doesn't do anything else. So as I said, it may vary using the millis. I didn't use a delay, I used the millis, which it's kind of more precise, but alternatively I would need to set up interrupts and use that, but that goes down to the microsecond level, and I don't think it's not so critical. What is important is the driver section. So the output, I might show you this. Okay, I'll turn it off while we're at it, so at least you can get to see. Okay, as you can see, this is just a normal board, no modifications done here at all. It's just the only thing I did is I said I put this 10K, replaced the 10K resistor because the SMD one here was kind of dodgy and broken. It wasn't really working well, which is one of the reasons why I blew it in the first place. But this board, okay, this was kind of course, if you look at the other side, as you can see, I don't know if it focuses it. Yeah, basically. As you can see, it has pretty many wires on. As you can see, I soldered some directly. For example, this is a trigger wire. I soldered it directly to the collector. You can solder it anywhere. I mean, it was, they won't fit all on the IC outline layout, because this is way too thin here. Okay, yeah, you see, it's never gonna be able to solder everything. So I soldered a couple on there, then I scraped some tracks to solder, and I soldered them on the tracks. I soldered here, and I put some hot glue to keep the wires from breaking off. And these three, I soldered the 3 switches directly on the normally open contact. The other side is ground. So, I mean, most of these are pretty easy. The most difficult ones are actually the ones pertaining the display here, as you can see. Here you can see a little one that I scraped and soldered on, and then put some hot glue again. This is it was necessary because it's kind of, there's not a lot of space. Those of you who have done, I don't know, maybe if you remember the PlayStation mods or stuff like that, using smaller wires, or it's kind of like straightforward. But yeah, I didn't have my thin copper wire, so I ripped off some of this flat cable wire, which is not bad, but it's multi-strand, and when you need to solder a multi-strand wire on thin tracks, it's never a good idea. But that's what I had, and I kept it like that. This is way too big. All these wires here are an overkill, so it's best to use. I have like a copper enameled wire, and if you cut them the right length and just scrape the ends off, it's fine. They're light. They don't when you move this PCB around, it doesn't put a lot of strain on the soldering joints, and so they won't break. What you should do here is stick this. I mean, apart from the the mess here, as you can see, it's like kind of nearly fully wired. This will fit if you kind of like squash it under here, or even rotate it and squash it under here. It will like fit underneath. there is enough space. It's all, if you look at it, it's all wire. So kind of can be neat. I put some tape on this beeper because it was really annoying. So yeah, that's why you don't hear it too loud, but okay, you can remove it when it's working. Okay, so I will run these tests with a battery, see if it works, and report back. And hopefully, I don't know, if something blows up, it's probably due to the driver section, because on the scope, well, it looks pretty clean. The output with a normal power supply, I mean limited to 5 amps. If I short this, it's always, of course, very clean. The FETs are working well. The output, which I measured, by the way, the output section, you can pick it up from the gate here, or you can detect it from, I don't know if you see this transistor. These are, one is an NPN, one is a PNP, and they're driven by this transistor here. This is this output here, and that's in the other output. They're both connected together. So you can put your, I don't know, tester lead or scope lead either here on this emitter or that one. And now it's the same, or pick it up from this resistor array here. By the way, the modified or the other revision of this, based on this version, has 2 other resistors put right here where my nail is. Or wait, maybe I can show you with this little wire. One here and one here. And they pick the voltage off this. This is actually a plus. It's coming from, if you see this diode, it's coming off here. Okay, from the cap side, not from the positive side, because this goes down. And so this diode prevents the reverse voltage. And there's a plus line going down here, and goes through this 30 ohm resistor. And then there is this, I believe it's a 4.7K, I don't remember. Anyhow, it goes through here, and it's driving these two. And this first transistor here is on the base, which is here. It's receiving the signal from pin number 4, counting from the top, from the Arduino. This is the first driver, which drives both of these two. It turns one on, turns one off, or vice versa. And it does this using, let's say it's negated. So when the base is conducting, it's off. When the base is not conducting, it's on. So keeping that in mind. The driver section is, you get a negative pulse here. It's not a positive pulse. So they added these 2 resistors here. I tried to make out what the circuit was. Something changed, but I don't have the PCB, so I can't really trace it out. But anyhow, I've seen this through this video that was sent to me by this other person who has the other revision. Okay, so I don't know, I think that's just about it. Right, remember the plus here, I separated it just for convenience, but when you're using it, either connect both terminals here or both terminals here. You no need to use this trace. I mean, it's a thick trace, but why risk, having 2 screws instead of just one, and screw it well, screw them both well, because if you have a very, very slight or not good contact, it's a disaster. Remember, these things absorb instantaneous current. It's very short peaks. You've seen it like 20, 25 milliseconds. If everything is fine, you can spot weld with 20 milliseconds if you have a good battery, short enough leads, and they're screwed on well. Okay, as I said, I prefer using AGM batteries. I have 2S 5000, 6000 milliampere hour lipos, but I don't know. I'm not so comfortable having this lipo sitting on my desk while I'm soldering, and if something goes wrong, and these get stuck, and the FETs don't explode. If they do, anyhow, it's a short. They rarely open. You got this battery sitting there, and it's, probably will overcurrent and shorten and catch fire or expand. As I said, these batteries, they're very powerful, the lipos. There is one thing that is terrible about them, and it's called thermal runaway. if you had one cell and you were using one cell alone, it would be less risky. Unfortunately, you just, of 3 cells or whatever, if just one cell, for whatever reason, overheats, it's gonna just transfer the heat, and the cell next to it will catch fire and so on. As soon as they're ruptured, the lithium reacts very violently with the humidity in the air, and yeah, they catch fire, and you're not going to put them out. I mean, they're just going to keep on burning. I mean, as I said, if you're out in the field, you're okay. You're just let it burn, dig a hole, and put it under, whatever, even if it's kind of polluting. The toxic, of course, fumes out of it they're very, very toxic and damaging. So for your eyes and for your lungs. So as I said, knowing all this, I really don't suggest risking it. If you have just even a small motorcycle battery, it's much better. It's much safer. Doesn't mean you're not going to burn yourself or maybe burn the table, but it's not going to catch fire for sure. Never has and never will be. So keep that in mind. Okay, so that's it.